Now in example 2, we have a canning factory who wants to use as little metal as possible to make its cans. So it considers these two can sizes that hold about the same amount. One is 4.5 inches tall with a radius of 4.2 inches, and another one is 9.6 inches tall with a radius of, which one are we going to change? Let's make this 2.5 inches to match our picture. Okay, which can should they use and why? So we want to use as little metal as possible. If we're using metal, we're making the outside of the can. So we've got to figure out the area of the outside of the can. So that's a surface area. Now, we have a formula for a cylinder. We're going to break it down first, and then I'll show you how the formula for the cylinder works. So first of all, let's look at this can here. Oops, I'll move that up just a bit. There we go. So let's look at this can here. We've got kind of three pieces. There's the top piece here. There's the bottom piece down here. And then there's the side that goes all the way around. Now the top and the bottom, those are just circles. And we saw that the area of a circle, so the area of the top in this case would be pi r squared. So that would be pi times the radius, which is 4.2 squared. And that would give me, let's throw that into our calculator really quickly, pi times 4.2 squared equals 55 we'll go to one decimal place because that's what they've given us, 0.4, and my units are inches squared. By the way, if you're doing inches, we can write inches just with two little dots, but as soon as we go into squaring it or cubing it, let's write inches IN. Just is much easier to make sense of. Now the bottom, well, that's still just a circle, just pi r squared, same radius, pi 4.2 squared, same area, 55.4 square inches. Now the side is a little bit more complicated. So if you think about it, think about if you've ever taken a label off of a can, for example, and if you can take it out really carefully and roll it out, it makes a rectangle. Now, the one dimension of the rectangle is just the height, the 4.5 inches, but the other one, you have to remember, it wraps all the way around. So the length of this thing is the distance around the circle. Now we know the distance around the circle is the circumference, and the circumference is either 2 pi r or pi times the diameter. Now, in reference to a cylinder, we're going to use 2 pi r pretty much exclusively. So let's look at the area of the side. Whoops, the area of the side would be equal to the length, which is the circumference, which is 2 pi r, times the width of that label, or the side of the can, which is the height. So it's 2 pi r(h). So the circumference, 2 pi r, 2 times pi times the radius, times the width, which in this case is the height, is 4.5. So 2 times pi times 4.2 times 4.5 gives me 118.8, and again, inches squared. And then we have to add those three things together. So the total would be 55.4 plus 55.4 plus 118.8. I'll just throw that into our calculator super quickly. Oops. And I get 229.6 square inches. So that is the surface area of the can. That's how much metal it would take to make that can. Now, here's the formula for a cylinder. So the surface area for a cylinder is 2 pi r squared plus 2 pi r(h). Okay, two circles, that's the top and the bottom. So write on your formula, grab your formula sheet right now and write on it that the 2 pi r squared is just the top and the bottom of your cylinder. 2 pi r(h), that's the area of the side. Remember, this length is the circumference of the circle, the width is the height of the can, so this is the area of the side. So if ever you need just the side, you just need the 2 pi RH. If ever you need just the top and bottom, or one of them, you can use one circle, or you can use 2 circles. So that's how that's broken down. So let's use that formula now for this cylinder. So the surface area here is equal to 2 pi r squared plus 2 pi RH. So 2 pi, the radius is 2.5 squared plus 2 pi, 2.5 times 9.6, and 2 times pi times 2.5 squared. Again, remember 2.5 squared is 2.5 times 2.5. That's 39.3. Going to one decimal place, and then 2 times pi times 2.5 times 9.6 gives me 150.8. So 39.3 plus 150.8 is 190.1 inches squared. Now if we want to compare these two, this is 229 inches squared, this is 190.1 inches squared. The company wants to use less material, so we want, this one would be better, so the taller can would be the better choice. Because less material is required.